Now let's talk about spheres. So you can think of spheres as being the three-dimensional version of a circle, which is a two-dimensional object. So remember, for circles, you always have a center. So spheres always have a center, but now it's a three-dimensional point. And what else do circles have? They have a radius. Same thing for a sphere. You have a radius, r. So now you can think of a sphere in our three-dimensional system. And I apologize ahead of time. This is going to be the best sphere I can draw on this thing. So I have some kind of, think of a ball. Right? A ball is like a basketball is a sphere. And spheres have this nice standard equation formula. It's very similar to the standard equation of a circle. Equals r squared. Here's the standard equation of a sphere. So if you just took away the z minus z naught part, this part right here, it would be the equation of a circle, but now I have the equation of a sphere. All right, so let's try to find the equation of a sphere. So let's look at this problem. We're gonna find the standard equation of the sphere that has the points (5, -2, 3) and 0, 4, -3 as endpoints of a diameter. So think about a diameter, right? If I have a diameter of the sphere, and really this should be this is a sphere here, okay? But if I have a diameter, halfway between those, the midpoint of those points is my center. So here, between those 2 points, I have my center of my sphere. So we need to find the midpoint of those 2 points. So let's do that. The center of the sphere is, so to find midpoints, you add up the coordinates and divide by 2. So 5 plus 0 divided by 2, -2 plus 4 divided by 2, and 3 plus -3 divided by 2. So what center am I getting? 5 halves, 1, and 0. So this would be, because this is my center, remember this in my standard equation formula, this is that point, x naught, y naught, and z naught. So I have the center of a sphere, which is great, but in order for me to write the equation of that sphere, I need to find the radius. So our next goal is we need to find the radius. Well, the radius, remember what the radius is. It's the distance from the center to any point on the sphere. And I was given 2 points on the sphere. So you can go back. We're going to find the distance between our center and then pick one of these 2 points that was given to me that I know is on the sphere. So the one I'm going to choose is the second point right here. It doesn't matter which one you pick. So let's go for this one. And I'm going to find the distance between those 2 points. So the radius will be the square root. So maybe I'll write it down here so we have it. That point that I'm going to use is the point 0, 4, negative 3. So 0 minus 5/2 squared, 4 minus 1 squared, and negative 3 minus 0 squared. So you're going to square these. You'll get 25 over 4, 9 and 9. If you want to simplify this, which it's probably a good idea that you do that, I'm going to get a common denominator. So if I add these together, you're going to get the square root of 97 over 4. And that simplifies down to, well, let's just leave it like that. So that's R. So we're ready to write the equation of our sphere. Now that we have the center and the radius, we're going to go back to our standard equation there. So it's x minus your center, 5/2 squared, y minus 1 squared, and then it's z minus 0. So I'm just going to write z squared equals r squared. And if you square r, it's just going to get rid of the square root. And there's my standard equation for this sphere.